And we're live. Welcome back to the Beanie Brief. I'm not even wearing a beanie today. I need to get myself together. Basically, we're talking about Google DeepMind and the crazy stuff they're doing in AI again. So if you didn't hear, Google DeepMind might have just cracked mathematics. This is kind of counterintuitive because when I first thought about this, I thought, well, AI is based on mathematics. Surely it lends itself to these problems really well. And it kind of does. But just because it's based on mathematics doesn't mean that it actually understands mathematics. But that might be about to change because Google DeepMind managed to train a neural network, an entire system to be fair, on mathematical theories, and it was able to come up with its own one on the structure of knots, which seems quite simple to us, but is actually not. And there are some theorems about knots and the structure of knots, but now there's an AI theorem about knots. And now I'm not going to read through this whole article, but essentially this is really interesting because artificial intelligence over the last few years has become more and more useful in sort of theoretical physics, in also in biology, in especially pandemics, modeling of diseases, things like that. Obviously, there's been a huge attention, and that's kind of taken away from the theory and from the mathematics side of things in other aspects. So, like before COVID, we were talking about using AI to solve to generate 3D models and to detect the difference between cats and dogs. Now, I think partly because of COVID and because of the focus on the theory and mathematics and science, that actually these algorithms are getting way more powerful than we thought that they would within that same timescale, because we're not as distracted by all of the amazing things that AI could do. And we actually needed to use AI to solve really difficult problems. We've seen incredible leaps forward in sort of the computation of proteins, a lot of biology stuff, a lot of mathematics stuff, and this is really just the latest part of that. So Google DeepMind, always making breakthroughs. This is super interesting. I'm not going to read through it because it can be quite boring on camera, but Google DeepMind have made a huge leap forward in terms of mathematical modeling. And the interesting thing about this is that it worked alongside human mathematicians. It was an additional tool, but it was a tool that could think for itself. And I think that's the best way to look at artificial intelligence. It's not a thing on its own, but it is a very powerful tool in our toolbox, as all software is. And so this is just fascinating for me. All right, next article, moving on. I don't know whether you guys knew this, but OpenAI's GPT-3 model is on an API, and up until recently, it has been closed. You had to apply to a wait list, and then you would be given an API key, and then you've been put rate limits on it, and if you go over those limits, you have to pay, or they just kick you off the platform. But actually in late November, they opened this up, and I didn't know. This wasn't communicated to me, but it might be because I was already a member of the API, so I already had access, but it is now generally available. You can sign up, and if you want to, you can spend money using GPT-3. Now, interestingly, they still have the same type of limitations as they did before, so they're very strict on what you can use GPT-3 for. They have the new codex model, which is trained on which is a GPT-3 model trained on code for generating code. That's what powers GitHub Copilot. And if you want to use GPT-3 not through OpenAI's API, you can use it in the Microsoft Azure cloud exclusively. So this is kind of a bit of a divisive topic because GPT-3 is arguably one of the most advanced AI models we've ever seen. It is super complex, and it is also enormous, and that means that people can't really run it on normal devices. It's just too big to compute locally. It has to be run in a data center, and it has to be trained in a data center. And I can't remember whether it was GPT-2 or GPT-3, but I heard that one of them cost $50 million just to train in compute time. So this is just like completely out of reach. So it's good that this API is opened up. I hope that they are a little bit more flexible with what you can build with it. I certainly am going to play around with it more. But yeah, this is kind of really interesting. The weird applications with GPT-3 are, it seems to have this weird generalization for problems that it wasn't built for. So like a good example is that this model was trained on natural language. It was trained on the internet and conversations, but because there are quite a lot of conversations about maths, GPT-3 can do basic math problems like 3 plus 3 and blah, blah, blah. because it has just learnt that because it's just read through a bunch of conversations where that was the topic. And so now it's able to do those tasks to a really good standard, even sometimes better than models that were designed for those problems, because it's just learnt by accident. People joining the chat, hello, welcome to you all. Thank you for all your nice messages. Hello, 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 Jarvis. Hello, Jarvis lover. All right, we've got 2 more topics to talk about. This is kind of a weird one, but I don't know whether you knew this, but iRobot's Roomba have now updated their AI to avoid knocking over your Christmas tree. Apparently this was a problem last year, where if you had these things driving around the house, weirdly people get these for Christmas, that it would knock over stuff. Now they have been developing these robots for quite a while and they still look the same, but actually over the years these have become really advanced. So Roomba will now map your home in 3D for objects, for furniture, for Christmas trees. It will then take that model, upload it to their cloud, which I think you have to subscribe to, so interesting business model, and it will actually then communicate that with any other Roomba robots you have, so that all of them have the same information. And that means that if you were to move your robots around, they would still understand because the robot mate has kind of learnt that house, that environment, already, and it's synchronized with your account. So this is kind of weird because as a company, iRobot, which is a terrifying company name, they have 3D models of everybody's houses, or at least like rudimentary 3D mappings of everybody's homes. And I don't know how people feel about that. I'm personally fine with that. But you could use that information for other stuff, like perhaps there's an optimum layout that it could start suggesting for your furniture if it knows where all your furniture are. I tend to just go off on a complete tangent with when I see things like this. But yeah, no more Christmas tree knockings over going on. And then just moving over to another weird robot topic. This is just something to finish off on today. These delivery robots stuck in the snow. I think that this type of stuff is the future, but this just goes to show that when designing these things, I mean, these companies are raising hundreds of millions of dollars in funding, and they haven't even considered the snow, which kind of goes to show that obviously in an arid, I don't know where this is, it's in Estonia. Snow is a thing. It happens every year for about 3 or 4 months, maybe longer, and this is a problem that is going to come up every single year. And so these products, this service that people will depend on, just as people have started depending on Uber and delivery drivers for food and things like that, people depend on these services. And so they need, in my opinion, they need to be designed with these things in mind. But I think that might mean that we get chunkier robots as time goes on. I think these are really cool, little cute little helpers, but it might be that they just get like more beefy to take on the weather. I think it's a bit like the e-scooter revolution, where initially e-scooters were like these sort of normal scooters that were being dropped on the street, and now they're starting to get like beefy because they understand that they're used by loads of people. And I think the average lifespan of an e-scooter is 30 days because they just get abused and chucked around and whatever. So they've got to get like stronger and more robust in order to actually make a profit. And I think it might be the same with these. I think these probably wear down quite easily as well, which is kind of interesting. Anyway, that was what I wanted to end on. Thank you so much for watching the live stream if you're watching live, and if not, make sure you're subscribed and you got the notification bell on so you know when I go live, and tell me what you want me to talk about next. I'm doing these hopefully every single weekday, and so let me know in the comments what you want me to talk about. Thanks guys for showing up,